Gravity keeps us stuck to this planet, but what is it really?
Well, in 1915, Einstein published his theory of general relativity, looking at how gravity affects both space and time, which are connected and modeled by a fourth-dimensional continuum called spacetime.
Whoa, confused? It helps to visualize objects on a piece of fabric. Here, objects of greater masses warp the fabric, leading to what's called a gravitational field. Now imagine you have 2 points. For light, the shortest and straightest path is now actually warped within the field.
As Einstein's theory of special relativity postulates that light travels at a constant speed in a vacuum, no matter the reference frame.
Light should travel from the 2 points at the same speed, with or without gravitational acceleration. As speed is equal to distance over time, and the speed of light in a vacuum is fixed, the longer curved distance must mean that time also increases, essentially causing time dilation. The more intense the curve or gravitational field, the slower time gets, which is found closer towards the mass. Scientists have proven this through tests with atomic clocks and seen that time does in fact get slower when on the surface as opposed to points further out.
Now what if there's an object of mass so great that time stopped altogether? The black hole. At a certain point called the event horizon, gravity becomes so strong that the slope of the warped spacetime is entirely vertical, traveling infinitely downward. As the distance is infinite, time must also be infinite to maintain the constant. Now that's great and all, but infinity over infinity is undefined in math, meaning we don't really understand it. But that is why the center of the black hole is called a singularity, in mathematical terms signifying a point at which a function takes an infinite value. Now, if we're unsure about so much, what is the point of general relativity? Our GPS systems work with satellites that are orbiting the Earth at around 20,200 kilometers from the surface. At that point, their gravitational field is much smaller than that on Earth, meaning that their time passes faster. We had to use Einstein's equations to regulate our timings, or else distances and estimated times given by the GPS would be off. However, a current issue with general relativity is that it isn't compatible with the equations of quantum mechanics. If you can figure that connection out, perhaps we could solve the mysteries of the black hole. Who knows? Only time will tell.